Dear viewers, welcome to this session on video basics of digital video technology. I am Dr. Gowthaman, Deputy Director working in IGNOU, Indira Gandhi National Open University. Let us begin with the learning outcome of this session. After watching this video, you will be able to explain the concept of video and video systems, discuss the characteristic of video streams, describe the capturing of digital video, and will be able to discuss the video compression and streaming techniques. Also, you will be able to describe the computer configuration of digital video. Let's discuss the video basics. Video is an electronic medium for recording, copying, playback, broadcasting and display of moving visual media. Video was first developed for mechanical television systems, which were quickly replaced by cathode ray tube CRT system, which were later replaced by flat panel displays of several types. Video systems vary in display resolution, aspect ratio, aspect rate, color capabilities and other qualities. Analog and digital variants exist and can be carried on a variety of media, including radio broadcast, magnetic tape, optical disc, computer files and network streamings. There are two types of videos are called analog video and digital video. Let's see one by one. First, discuss about analog video, which were effectively used at early stage during especially our 1950s. Analog television is the original television technology that uses analog signals to transmit video and audio. In non-analog televisions broadcast, the brightness, colors and sound are represented by amplitude, phase and frequency of an analog signal. Video technology was first developed for mechanical television system, which were quickly replaced by cathode ray tube, that's already we covered. But several new technologies for video displayed devices have been invented. Video was originally exclusively a live technology which was invented by Charles Kingsburg led and Ambach's research team developed one of the first practical video tape records. In 1951, the first VTR captured live image from television cameras by writing the camera's electrical signal onto magnetic video tape. So, you can see that example of the screen. What you can see that analog video signal from a PlayStation, that's like how it's display that video, transfer the video signals are showing in the image. Now think about a digital video, which is used as of now. The digital television is the transmission of television audio visual signals using digital encoding, in contrast to the earlier analog television technology, which was used in analog signals. At the time of its development, it was considered an innovative advancement and represented the first significant evolution television technology since the color televisions, which was introduced in year 1915. Digital video was later capable of higher quality and eventually much lower cost than that earlier technology. After the invention of the DVD in 1997 and later by Blu-ray disc in 2006, sales of videotape and recording equipment had been decreased rapidly in value and usage. Advances in computer technology allows even inexpensive personal computers and smartphones to capture, store, edit and transmit digital video, further reducing the cost of video production, allowing program makers and broadcasters to move to tapeless production. To advent of digital broadcasting and the subsequent digital television transitions in the process of relegating analog video to the status of legacy technology is most part of the world. Example, web-based videos. You can see YouTube is one of the example, and like another we can say like video used in LMS, which is on Moodle platform, that is also web-based. So what you can see there, that all the videos kept on the server. As a browser end, as a user, they can view the video. So this is the web-based technologies. But otherwise, if you watch from your home on your own computer, that's that video computer, just your computer-based video systems. Now let's discuss about various characteristics of video stream. The terms, the key terms, for example, we can say what is film rate per second. Why this is used in the format of like video streams? Number of frames per second. Frame rate is the frequency rate at which consecutive images or frames are captured or displayed. Frame rate may also be called the frame frequency and be expressed in hertz. As per quality standard, the specialization 25 frames per second for cinematic motion picture to the video. The minimum frame rate to achieve a comfortable illusion of moving image is about 16 frames per second. Then now we discuss about interlaced with progressive. Video can be interlaced or progressive. In progressive scan system, each refresh period updates all scan lines in each frame in sequence. When displaying a natively progressive broadcast or recorded signal, the result is optimum spatial resolution of both stationary and moving parts of the image. Interlacing was invented as a way to reduce flicker in early mechanical and CRT video display without increasing number of complete frames per second. Interlacing retains details while requiring lower bandwidth compared to the progressive scanning. Now just we will brief discussion on aspect ratio. When people use the still camera, the photography, the most common aspect ratio are 4:3 and 3:2 or more, and more recently found in consumer camera 16:9. Other aspect ratios such as 5:3 and 5:4 and 1:1 square frame rate are used in photography as well, particularly in medium format and large format. But what about video aspect ratio? Videographic aspect ratio are 4:3 or about 1.33:1. The universal video format of the 20th century aspect ratio are defined 16:9 or about 1.78:1 for high definition television and European digital television. Other cinema and video aspect ratio exist but are used infrequently. Aspect ratio describe the proportional relationship between the width and height of the video screens and video picture elements. All popular video formats are rectangular and so can be described by the ratio between width and height. The ratio width to the height for a traditional television screen is 4:3 or about 1.33:1. High definition televisions use an aspect ratio of 16:9 or about 1.78:1. The aspect ratio of full 35 mm film rate work with soundtrack, also known as the academic ratio, is 1.375:1. Now, how to compare? How to compare common cinema photography and traditional television screen? You can see on the screen, it shows the rectangle box with 3 different colors: blue, red and green. If you see that green box, rectangle box, which covers the ratio 1.33:1, where 1.33 is the width and height is 1. The similar way, if you see the aspect of red color, where the height is as the same 1, but whereas the width is 1.85. The similar way, blue, height is same as 1, but whereas the width is 2.35. This way the video aspect ratios are defined. Let's think about the color model and depth. The basic color model, the video color representation and maps encoded color values to visible colors reproduced by the system. The number of distinct colors a pixel can represent depends on color depth expressed in the number of bits per pixel. A common way to reduce the amount of data is required in digital video is by chroma subsampling. Example 4:4:4 or 4:2:2, etc. What you can see on the screen, it's one of the example of UV color pan where that input value y is equal to 0.5. Now come to the video quality. How we can ensure about this is the best video? Is there any quality parameter in place? Yes. Video quality can be measured with format metrics like peak signal to noise ratio PSNR or through subjective video quality assessment using expert observation. So that purpose, video compression methods and the technologies are used. Uncompressed video delivers maximum quality but with a high data rate. A variety of methods are used to compress video streams, with most effective ones using a group of pictures GOP. That GOP to reduce the spatial and temporal redundancy. The temporal redundancy can be reduced by registering difference between the frames. This task is known as interframe compression, including motion compensation and other techniques. The most modern compression standards are MPEG-2 used for DVD, Blu-ray and satellite televisions, and MPEG-4 that is used for advanced video coding high definition AVCST and mobile phones, 3G and 5G and internet. And we will discuss about the stereoscopic is the one of the characteristic of video stream. Stereoscopic video for 3D film and other applications can be displayed using several methods. One method we can say two channel method, a right channel for the right eye and a left channel for the left eye. Both channels may be viewed simultaneously by using light polarization filters 90 degrees of off axis from each other on two video projectors. These separately polarized channels are wearing eyeglasses with matching polarization filters. And another method, Anagali 3D method, where one channel is overlaid with two color coded layers. This left and right layer technique is occasionally used for network broadcast or recent Anagali released on 3D movies on DVD. Simple red can plastic glasses provide means to view the images discretely to form a stereoscopic view of the content. The latest method is on virtual reality method. One channel with alternate left and right frame for the corresponding eye using LCD shutter glasses that synchronize to the video to alternately block the image to each eye. So appropriate eye sees the correct frame. This method is the most common in computer virtual reality applications such as in a cave automatic virtual environment, but reduce the effective video frame rate by a factor of 2. Capturing digital video. Capturing digital video can be conceived of two different contexts. One where the source is analog and another one the source is digital. If you are using a video cassette player and a VHS tape as your storage or an analog video camera, you would require converting your video to digital format. The basic device used for this purpose, a video capture card attached to the computer. The device and its supporting software perform certain functions. What are the functions? It converts the analog signal to a digital signal and synchronizing with the video playback device and copy video. It has to do the process of signal reading and converting the video into an appropriate format, convert the image, compress the image or otherwise modify it to desired requirement, facilitate the storing and retrieval of the digital video. There are variety of video capture cards and software and their choice depending on various factors like source of video, the desired purpose and quality of the output of the digital file and format in which the video will be stored and processed. Different cards also permit different range of compression of video. If the source of the video is a digital device, say a digital handycam or a digital still camera with a video option, then the standard ports like Firewire or USB or Wi-Fi could be used depending on the output of the format of the camera. Generally, such devices have a built-in storage medium like memory card or external hard disk. In such cases, the process is simply that of reading and copying the digital video files onto a hard disk of your computer. So, it has some electronic components. Special electronic circuitry is required to capture the video from analog video sources. At the several level of this function is typically performed by a dedicated video capture device. Depending on the device, the resulting video stream may be conveyed to external circuitry via computer bus, example PCI 104 or PCIe electronics, or a communications interface such as USB, Ethernet or Wi-Fi, or stored in mass storage memory in the device itself, that is digital video recorder. Now you can see that few examples how these components are looks like. That same thing you can see the screen. Let us discuss about video compression and streaming video. Based on the purpose of your video, you might want it stored as a DVD or USB or in internet or to a particular hard disk. For this purpose, you may also want to upload your video onto the web, that is on internet. You have to do certain steps. Each of these requirements will have a different implication for the image size, file size and format of your video. Playing back a video from a video player or a computer involves that reading the file. That's reading means the signals need to be decoded format and sending the portion of the file in the right sequence from the storage area to the monitor. One would also expect a smooth playback of the video with the audio properly synchronized. In fact, the eyes and ears together can easily discern even slightest mismatch between the audio and video. A simple rule of thumb, smaller file size will be smoothly transferred. In case a computer, it would also involve speeds and the capacity of that drive and the memory RAM and the graphics card. To the extent the files is within the capacity of the computer, you can be sure of smooth video playback. If the file is being played from the internet, the bandwidth of the internet connection and the speed of the server serving of the video file also matters, which are related to streaming of the video. So, how do we ensure a smooth playback? What characteristics of the video file will affect the what characteristics of the video file will affect its smoother transfer. Image size of video is identical that you used for a still image, it refers to the width and height of the video. As we noted earlier, the video window can be resized. So, unlike television stream, where the image is always full screen, your video could occupy a portion of your screen, the remaining being used for other text graphics. Simply put, large image size, large file size, you can resize the video using any video editing software. The format of video file also affects the size. There are large number of video formats and large number of media players too. Some examples are audio video interface AVI files, QuickTime files, MPEG video files, movie files, Apple QuickTime movie files, Flash file, Adobe Flash files. All these file formats are specific to the video capture card which you are using, and you may not have much more choices while handling video from analog sources. Also, camera and video editing software are built around specific file format. So, even with digital files, you may not have too much of choice again. So, even with digital files, you may not have too much of choice. Again, if you wish to serve your files through the web, the operating system and support software on the web server will restrict your choice. So, for practical reasons, you may have to work with few video formats, but you can still convert digital video files from one format to another format using video converter software. Like in the case of still images, compression techniques are adapted to reduce file size. In order to optimize the playback capability, the technique of streaming is adapted. Streaming basically involves enabling a player software to play the file as soon as predefined part of it is downloaded. The video begins playing while the file is progressively being downloaded. At the server end, it involves making copies of the video file available and enabling the certain features to the users. So, then when we think about that video file size and the storage capacities and also streaming methods, like we have to consider about that issue, like also storing the graphics into the graphics card, which is more important. Most graphics and video tags are handled by the graphics card. So, graphics card is supported by the large enough memory, so which enables a smooth display of the video. And also think about that the storage capacity. Nowadays, it's coming on like hard disks are available in terabyte basis. It's not like earlier. So, when you are having like higher memory, then according to your requirement, you can adapt your hard disks. And video capture card also again more important. Video capture card which is connected to the motherboard, this card will process all the audio and video input and output streams. This is one of the important component. Different kinds of connectors depending on the source softwares control the video recorders. Selection of cam card also it plays very vital role. Traditionally, two major components of the video recording system, namely camera and the recorder, were separate units. This imposed various restrictions on their usage. Two people at least to operate the two units need to interface them and workflow management. In typical studio recording situation where multiple camera are used simultaneously, sharing of recorder made very good sense of camcorders. On the other hand, combined these two units into one. So, digital video had the camera, the image for recording the light and recording media and rolled into one compact unit. Camcorder range from very small, lightweight handheld cameras to broadcast quality professional cameras. As we mentioned, they can support a varied range of storage devices like videos, tabs, USB, CD, DVD, hard disk and of late. See what you can also think about that, what are the cables and connectors need to be used. So, which are involving that components, composite and again firewire, Wi-Fi and USB. These you can adapt as per your needs, requirement. In case of the component, the video signal is analyzed into the 3 separate signals, that is RY, BY and Y. Here R stands for red, B stands for blue and Y for luminance or brightness. So, let us summarize this session. We discussed the concept of video and video systems. We described the characteristics of video streams. We also explained for how to capturing the digital video, and we discussed few techniques of video compression and streaming videos. We also discussed about the computer components and configuration for digital videos. With this, I conclude this session. Thank you.